He was just declared cancer-free today, so that's awesome.
That's cool. A good day.
Yeah, great day. All right, here's questions. It says number six says an airplane flies at an altitude of 5 miles. At an altitude of 5 miles, okay, toward a point directly over an observer. So here's my observer right here. That's the guy. Okay. And the plane flies an altitude of 5 miles toward a point. Okay, so this is what he's doing. He's flying this way. And the height of this is 5 miles. The speed of the plane is 600 miles per hour. And find the rate at which the angle of elevation is changing. So the angle of elevation is this angle right here. That's theta. So drawing that picture is an important part of this problem. Do you get that? So that
Yeah,
so
right.
this is also 5. So we'll call that 5. You could also draw it like this. So that's a right angle here. It's a right angle there. This angle is also that same angle theta. The angle of depression is the same as the angle of elevation because they're parallel lines.
Right, because it's like alternate interior angle or something.
Yes.
Okay.
So it says um the speed of the plane is 600 miles per hour. Find the rate. So that's the change. This is the change. This is d. We'll call that x. That's dx with respect to time. Is actually going to be a negative number because it's getting smaller, right? Because we'll call this x right here. Got it?
Yeah.
I mean, you could have drawn the picture kind of the other way if you wanted to, like this right here. But now that I've got it drawn, let's just keep it like that. So it's still getting smaller, right? So we've got x, we've got theta, and then we have 5. So how is theta right here related to 5 and x? Well, that's the opposite and the adjacent, right? So what relates the opposite and adjacent together?
Um. So cot tangent.
Tangent is the opposite over adjacent. So the tangent equals 5 over x. So if I take the derivative of both sides, so that's equal to, I guess you could also call it the cotangent. Do you know the derivative of cotangent?
It's like I think it's minus cosecant squared x.
Okay, that might be just a little bit easier to work with because then the derivative will just be easier to find, right? Because then I don't have
Okay.
x to the -1. I mean, I guess you can do that as well. We can do it either way, but let's try cotangent. So if I take the derivative of both sides, if I take the derivative with respect to t of both sides of this equation, I get 1/5 dx dt on the right side, 1/5 dx dt. And what'd you say the derivative of cotangent is?
Minus cosecant squared x.
Minus cosecant squared theta times d theta dt,
That's
right?
true.
Because it's the chain rule. So let's plug in all the stuff that we have. Dx dt is -500 or -600. So -600 divided by 5 equals d theta dt times whatever the cosine of that angle is. And what's the cosine of that angle? It is, they said when the angle is 30. So when it's 30, what's the cosine of 30? Think of your unit circle. The cosine of 30 is the x coordinate right here. So it's √3/2, I think.
Yeah. Is it? Yeah, it is.
So root 3 over 2 squared, right? And it's negative of that. So that's negative 9/4 d theta dt equals what's negative 600 divided by 5? That would be 120, negative 120. Check that for me. Negative 120. D theta dt equals negative 120 times negative 4/9. So the negatives cancel out. 9 and the 120 can be divided by 3. So that's 3 over 40. So 40 times 4 is 160 over 3. D theta dt is 160 over 3 radians per, was this in seconds? Or hours? Radians per hour? You have the answer key?
Let me see. Well, I don't have the answer key now.
Okay. What's the derivative of cotangent theta? It's negative 1 over sine x. I think maybe
The arc sine of x is
is that the same as cosine? No, that's not. I don't think you gave me the right formula for that. So that would make it wrong.
Is it not? Oh, I thought it was cotangent derivative. Yeah, it's minus cosecant squared x.
Maybe I'm just looking it up. Cotangent. The derivative of cotangent x is negative cosecant squared of x.
Yeah, I said that, I thought.
Oh, you said cosine, I thought.
Oh, okay, this is okay. I
Okay.
probably did say cosine, but it was like an accident. Okay.
Yeah, that's okay. It's all right. We can fix it. Negative cosecant squared of x. So what's the cosecant of? Well, I think that's easier because the cosecant is 1 over the sine, which is just going to be 2, right? The sine is 1/2, so it's just 2. So this just becomes negative 4. So negative 4 divided by 120. Yeah, that's just easier. Right? So negative 120 divided by 4 is 30. Right? Negative 120 divided by negative 4, which equals positive 30. So 30, sorry, I was saying radians, it's degrees. It's 30 degrees per hour, I believe is the answer.
Okay, that makes more sense.
Yeah. Okay, so number 7, a man 6 feet tall walks at a rate of 2 feet per second toward a light that is 20 feet above the ground. So here's the light, and that's 20 feet above the ground. So draw my picture, and he is walking. It's a 6 foot tall man, so that's 6 right there. There's his head right there. And he's walking at a rate of, so dx dt is equal to 2 feet per second. 2 feet per second. Let's try that again. 2 feet per second. So he's walking to the right at 2 feet per second. I'm looking back at my last problem and wondering if that dx dt should have been positive 600 miles per hour. but that distance is getting smaller. The X distance is getting smaller. So I think negative was correct. Well, let's just think about what that angle's what's happening with that angle. Is it getting bigger or smaller? As this gets closer, is it getting bigger or smaller? That angle's getting, yeah, so I think we're right about
yeah,
that.
he was getting, okay.
Yeah, I think that's right. So 6 feet tall, walks toward a light that is 20 feet above the ground. When he is 10 feet from the base of the light, at what rate is the length of his shadow moving? 2 feet per second toward a light. So his shadow is cast this way. That's his shadow right there. I'll make it black like a shadow. That's his shadow because the light is coming from here, right? And it's casting a shadow on the ground behind him, but he's walking toward the light. So okay, so they want to know, and these are tricky. At what rate is the length of his shadow? That's L right here. So let's label that L. They want to know DL dt at the point that he's 5 feet. So we have to figure out how all of those things are related to each other. So these two triangles are similar triangles. This black one that I'm drawing in here is similar to the red one, the small red one, right?
All right.
Those are similar triangles. So let's call this distance here X. X is from the man to the base, right? Got it? So we're going to call that X. So the formula we're going to set up is see, six is to L as 20 is to X plus L, right? That's that proportion we can set up. Got it?
Yeah.
Trying to think of it, and they say what is the rate is the length of his shadow moving? That's L. Yeah, I think this is all we need. So let's cross multiply. I'll do this to the right. So 6x plus 6L equals 20L. Oh, something doesn't seem right about this. So 6x equals 14L. Something doesn't seem right. Because if I take the derivative of this, I feel like I'm missing something here. If I take the derivative of this, I'm going to get rid of my X and my L. So something's not right about how I set this up. Let's come back to this one. Because that's got me stumped a little bit right here. I'll have to think about that. Whoops. You undo that. All right, now I'm struggling to move this stuff out the way. Let me just erase it. All right, let's do the conical tank one. This seems a little bit easier. The conical tank with vertex down. So here's the cone. Here's a tank with the vertex down. Is 6 feet across at the top. So the radius is 3, right? So that's 6. So that's 3. And 12 feet deep. So that's 12. So there's a ratio between the radius and the height. The radius to the height is 3 to 12 or 1 to 4. Right? Got that? Water
Yeah.
flowing out of the tank, so it's going down at a rate of that many feet per second. So water's flowing out, so that's the volume. dV dt, the change in volume is -8 cubic feet per minute. Find the rate of change of the depth of the water. So that's the dH dt. That's what they want us to find when the water is 5 feet deep. This is a much more straightforward problem. So the volume equation for a conical tank, what is that? 1/3 pi r squared times h.
Yeah.
Is that right? So let's
Yeah.
rewrite. We want to find dH dt. So let's rewrite r. Use that formula we just had to rewrite r in terms of h, because I want to substitute r out of the equation. So r equals h divided by 4. Right? So let's rewrite this equation in terms of just h by substituting in h over 4 for r. And simplifying that gives us, and I'm just going to leave these numbers here because you'll see why. 3 times 4 squared times h cubed. Just leave those numbers there. Don't even bother multiplying them out, as you'll see probably in a second why that's usually helpful. So now I'm going to take the derivative. So that's equal to v. So I'm going to take the derivative with respect to time of both of these things. So dv dt is equal to, let's do the chain rule here, 3h squared dH dt. See what I did there? Times
Yeah.
pi over 3 times 4 squared. And you'll see why I decided not to multiply the 3 and the 4 together, because you can see, oh, look, the 3 cancels out. That usually happens. Something like that usually happens. So your equation is pi over 16 times h squared times dH dt equals dV dt. And now you can plug in all the things you've got. You've got, it says when the water is 5 feet deep. So if the height is 5, h, I'm plugging in 5 for the h. And then I'm plugging in, so 25 pi over 16 dH dt equals dV dt, which they said was 8. Right? So it says find the rate of change of the depth of water. That's dH dt I'm trying to solve for. So dH dt is just going to equal, dH dt is going to equal 8 times 16 over 25 pi. And you can just now multiply those out because you see nothing's going to cancel out, because 8 and 16 all just have a bunch of 2's in it. And 25 is just 5 squared in pi. And that would be feet per minute. So barring a mistake, I believe that's the answer for that one.
Okay. Yeah.
All right, good. You want me to whip off these 3, 4, 5, 6, or you want me to go back and try to work through number 7?
Just do these 4.
Okay. Yeah, we're out of time, unfortunately. Maybe next time I can catch up with you on number 7. I don't think it's probably difficult. I'm not seeing the equation off the top of my head. And it's probably much simpler than I'm making it out to be. So
Okay.
I'm assuming they want us to find the derivative of these.
Yeah.
All right,
This is what's it called? It's unit 5, and it's like critical points is what it is.
okay. So I'm going to take the derivative using the product rule. So the first one times the derivative of the second plus the second one times the derivative of the first, which is going to be 2 times x plus 2 to the first times the derivative of the inside, which is just 1. Right? So simplifying this gives me x squared plus 4x plus 4 plus 2x squared. I'm distributing this in 2x minus 2, and then I'm foiling it out with this one right here. 2x squared minus 2x plus 4x is plus 2x minus 4. Right? Which simplifies to 3x squared plus 6x. And then if they want, do they want you to find critical points so that they would want you to set this equal to 0,
Okay.
right? So setting that equal to 0, factor out a 3 and an x, and you're left with an x plus 2. So your zeros are 0 and -2 are your
Okay.
critical points. Are 0
Okay.
and -2. Got how I did that?
Yeah.
Number 4, the derivative of this is equal to, well, actually, let's not write the derivative of that. Let's first write what that equals. Let's simplify that so it's easier to take the derivative. So that's x to the 2/3 minus 4,
Right.
right? So then the derivative of that using the power rule is 2/3 x to the -1/3, which is the same as 2 over 3 times the third root of x. And there's no way to make that 0. Is it just 0 or also where it's undefined?
Probably just 0.
For critical points? I don't remember
Yeah.
what the rule is. I don't remember if you find out where it's also undefined or no. Just where the derivative equals 0 are the critical points?
Yeah, I believe it's just 0.
Okay. Number 5, so the derivative of this would be the, actually, does this factor? I don't know if we want to factor it. The top does factor, but it doesn't cancel out. So it's going to be low d high 2x minus 3 minus high x squared minus 3x minus 4 d low, which is just 1 all over low squared. So simplifying that would give you 2x squared minus 4x minus 3x is minus 7x plus 6 minus x squared plus 3x plus 4 all over x minus 2 squared, which simplifies to x squared minus 4x plus 10 all over x minus 2 squared. That does not factor, right? So what we're going to do is use the quadratic formula. So negative b, which is positive 4, plus or minus the square root of b squared minus 4ac. So that's going to be imaginary numbers all over 2a. Because
Okay.
you don't have any, those are complex, so non-real. Something doesn't feel right about that though, to me. Shouldn't you have, I mean, I'm just thinking about the graph of this thing. The graph of this thing is going to be h of x. You can also think of critical points as max and min points. Do they not include vertical asymptotes for critical points? I'm sorry, I haven't done this in a year or two, so I don't remember how this works. But that would equal x minus 4 times x plus 1, right? All over x minus 2,
Yeah.
right? If you factored it. So your zeros are going to be at 4 and -1. So -1 and positive 4. Those are your two zeros, and your vertical asymptote is at 2. And your
Yeah, I don't think a critical point is I mean, actually, I think it is, yeah. I
and
think it
then
is a
you're going to have a you're going to have a slant asymptote of some sort here, probably, right? So it's going to be something like this, maybe. So it'd be like maybe like this and like this. I'm just guessing without actually doing the work. So what would the critical points? I guess, yeah, you wouldn't have a max or a min. So no critical points, perhaps, for that one.
Okay.
You got it?
All right.
For number 6, taking the derivative of this is going to be the first times the derivative of the second, which is 1/2 1 minus x squared to the negative 1/2 times 2x, right? Plus the derivative of the second, or the second times the derivative of the first, so 1 minus x squared. So this we're going to have to simplify. That equals, those 2's cancel out. So that equals x squared over the square root of 1 minus x squared plus the square root of 1 minus x squared. So when do those equal each other, basically, is what we're trying to solve for, right? So setting that equal to 0 means I would say negative the square root of 1 minus x squared equals x squared all over the square root of 1 minus x squared. Multiply both sides by the square root 1 minus square root of x squared. That gives you negative 1 minus x squared equals x squared. So negative x plus x squared equals x squared. Oops, sorry, negative 1, not negative x. So negative 1 equals 0, and I don't have critical points. I do that right?
Okay, I guess.
We could graph it to see what it looks like, to see if you do get critical points in a graph, just to check. But it would be x times the square root of 1 minus x squared. And if I graph that, no, it seems like I should have critical points on this one. When I look at the graph, it looks like I do have critical points, so I think we did something wrong here.
Okay.
Let's see what I did wrong. X times the derivative 1/2 times 1 minus x squared to the negative 1/2 times, times negative 2x. There's my mistake. Okay. So that should have been negative 2x, which means I have negative x squared up here, which means I have negative x squared here, which means I have negative x squared here, negative x squared here. Yeah, this is the right answer. So I have negative 1 equals negative 2x squared. So x squared equals 1/2. So x equals plus or minus the square root of 1/2, which is the correct answer according to my graph. Because the graph looked like this. The graph was something like this. It was like something like that. So this max is the positive square root of 1/2, and this min is the negative square root of 1/2.
All right.
All right. Good about that?
Yeah.
All right, buddy. You have a good one. I'll catch you next.